All right, guys. So I'm Ryan. I'm going to be talking about weaponizing Splunk. Wow, these colors are going to suck with it. Sorry. Anyway, so I'm the Director of Security Engineering with TBG Security. We're a consulting firm based out of Boston doing offensive security. I got a few certs up there, so hopefully that shows that I know a little bit about what I'm talking about. So this talk, last year my team and I were on a pen test. We got internal access to the network. We're doing a little bit of recon and enumeration. We stumbled across a Splunk box. Upon navigating to the website, it automatically logged me in with admin credentials. It was like, that's awesome. Thanks, guys. But so then we took that and we thought about it. How can we actually leverage this into something that I can, attack this box or attack the rest of the network? So we came up with a custom application that we installed, gave us a shell on the box, and then we thought, well, how can I get even further? Well, in a few slides here, I'll talk about the deployment servers and universal forwarders and all of this stuff, but you can basically push out applications to all these universal forwarders that we have inside a customer network. So on top of installing an application, we also deployed out an application to every box in the customer network. So we took, a 2-week-long pen test in about 30 seconds. So that's pretty cool. Anyway, so what am I going to be here for? I hate this standard mic. This sucks. I like to walk around. And the lights got even worse now. Now no one can read anything. Other way? With the lights? No? Okay. So we're going to start out, I'm going to talk about briefly what Splunk is. Hopefully everybody at least has some idea what's going on with Splunk, if you're here. I'll talk about some of the misconfigurations that we've seen, usually just the basic stuff. Nobody changes their freaking password, things like that. And then we'll get into the meat of the talk, weaponizing Splunk. There's 3 attack surfaces that we'll be going into: attacking the server itself, attacking the rest of the organization, and then how we can actually leverage Splunk as almost like a C2. So actually, if I install Splunk on my attacking machine and collecting the data that way. And then I'll wrap up the talk with kind of talking about how you can mitigate this in your own environment. And since, actually, if anybody has any questions while I'm doing this, go ahead and raise your hand and we can address them as they come up. It'll just be easier than waiting until the end. So what is Splunk? As I said, hopefully you guys have some sort of idea because I'm not really going to get into all the details of it. But it is a log aggregation tool. All these devices that we have in our network, Windows machines, Linux boxes, net firewalls, everything that we have, Splunk's going to take all the logs and alerts that come out of those devices and put them into one location. As I said earlier, the universal forwarders, these allow you to collect those logs off all these disparate devices. If it doesn't send out syslog messages, you can install a universal forwarder on it and then pull in all those logs. So things like Windows logs are normally what you see. But any other custom web applications, if they don't syslog out, you can install the universal forwarder, tell it where the log is, and it'll collect them. What's really nice about these is they do allow command execution on the box. So if you need to run something like on a Linux box, I want to run netstat and collect the connections that are going on that machine and send those to Splunk so that I can review those over time. It will allow that. All these universal forwarders, they're actually sent out through what's called a deployment server. The deployment server allows you just basically a collection of all these machines, and you can separate them out by machine name or by the operating system is how you can categorize them. So the first screen you would see if you go to the deployment server, you would see all your list of clients that have the universal forwarder installed. You can click over and you can actually split them up into what they call categories or classes. So, for instance, if I had a Windows application, I only want to install that on Windows machines, not Linux machines. So I split them out and say, hey, here's all my Windows boxes based on operating system. Only install those apps. And that's what the apps, the last section here is apps. So those are the basics of Splunk. As I said, there's a ton more to look into and you actually could figure out with it. If anybody has any questions there, go ahead and ask them. Otherwise, we'll start getting into the regular stuff. Yes! All right. As I said, the basic misconfigurations that we see, I'd rather the dark. Let's just go dark. 9 times out of 10, I usually run into an organization that didn't change the default password. It's admin and changed me, obviously. Now, as of 6.5, Splunk does force a reset on that admin password upon installation, but, who upgrades all their software all the time? So we still do run into a lot of older machines where the passwords haven't been changed. The older versions, as I said, that at the beginning, the installation that we ran into, I think it was a 4.5 installation, and this was just last year. So that obviously shows people are not upgrading very well. Those automatically logged you in if you didn't have an enterprise license. I think that was really the main thing. And then a lot of times I don't see SSL turned on. It's one checkbox and a save button, really, to turn that on. So you can run man-of-the-middle attacks if you were seeing that. And finally, the universal forwarders and the Splunk box itself is usually running as a higher privileged user than it really needs. I see more the actual Splunk server software running as an underprivileged user, which is good. But those universal forwarders, nobody really wants to configure the permissions on every single log so that the universal forwarder can read them. So 9 times out of 10, I run into those boxes. Those are all running as root or system, which is awesome for us. So, actually weaponizing Splunk. So upon first getting into a server, that's what we're going to talk about when I get into the attacking the server part. What can we do when we get on that box? So first of all, we want to increase our intelligence. So let's look at the logs that are already in there. We can identify operating systems. I can identify the domain controllers, the exchange servers, everything else in the environment. Then, if Splunk is running as a privileged user account, I have read access to every file on the operating system. Let's pull in Etsy Shadow. Let's pull in Etsy Password. Whatever file you can come up with, let's pull it in. Let's look at it. And if you do it the right way, that doesn't get logged. So that's awesome. If we have administrator access, we can install applications, which can be any application, which can run any code that we want. So if you have a Python shell or if you have anything, you can run it. And then finally, we're going to talk about extracting the data, which is, all these configured files are on there. Let's look at the data that we can pull out of Splunk. That changed. Attacking the organization, we're going to get into actually how we can utilize Splunk to laterally move throughout the network and compromise everybody. And then the final part, attacking the data, we're actually going to use it for C2, so that's going to be cool. So, reviewing the logs. All the logs, since this is collecting all the logs, as I said, custom web applications, Windows logs, Linux logs, everything's in here. Let's start looking for things. Go to the search application, type in passwords, see what comes back. If it's a custom web application, a lot of times I've seen developers pull in the passwords. Why the heck not? No one else needs to see this except for me. Why would anybody be looking for passwords? It's pretty cool. We can get a good sense of the hours of operation. If we started looking at maybe, let's say, the Windows event code for logging in. I now have a list of users that say, okay, this shop runs 9 to 5. So I see all my logins at 9, I see all my logouts at 5, and I can actually probably pick out where lunch is too, because a lot of people log in and out there too. Or maybe I can see if it's a 24-hour shop. But now I have a list of users. These guys run the morning shift. These guys are in afternoon. These guys are a night shift. So it kind of gives you a lot of intelligence about a company. So let's actually go to the demo here. Oh, come on. Why are you not working? There it goes. Wow, that looks like crap in the light. Hold on. Let's see here. Let's just step through it. So the first stop here, if you click in the middle there, you're going to add data. So if the Splunk application itself is running as root, I'm going to look at monitoring a folder or a file. So let's click on monitor. Can we bring the lights down just a little bit so we can read some of it? Otherwise, it's not going to make any sense. So on the left over there, we're going to look at files and directories. Wow, that sucks. So I'm going to look at Etsy Password right here. And then I'm going to hit browse. And it's going to actually show it to me. Crap. Well, if we could see that, it would be the Etsy Password file. So I'd now be able to enumerate usernames there. So as long as you don't pass that screen right there and keep hitting next to finish it, this data didn't get indexed, it doesn't get logged, and I now can pull this down and look at it locally on my machine. If I need to pull up hashes, I can start cracking that, but no administrator would ever know that I was looking at any of these files, so no alerts are going off. Yeah, that might get a little better, hopefully. Alright, so that's kind of reviewing the logs. Everybody's cool with that? We're good? Alright, so let's start installing malicious applications. So I built an app called Splunk Shells. It does a bind shell or a reverse shell. It's just an interpreter, and it's just a proof of concept, basically, to show off the capabilities. Hopefully this one looks a little better since it's not white. So let's start up with Metasploit. Let's start up a handler. Then we'll start looking at the application. So we're setting up a handler right here to catch the shell. So our handler's set up. Now let's go actually to Splunk. So Splunk applications are basically just a zip file of folders and scripts that are running. Browse, we'll grab the zip file, and then we can install it. So what this does is it basically adds an application to Splunk and gives you a command line that you can run through the search and reporting application. So once we install it, we don't have to do a restart on the box, so no, again, that doesn't alert anybody. We'll just change one permission set that I don't think I can do in config files, or at least I haven't figured out which one it is. So you do have to set this, and this is only in 6.5. So we'll hit save, and then we'll go to search and reporting and actually execute the reverse shell. So from the command line, I can specify, do I want a reverse shell, do I want a bind shell, who do I need to talk to, and what port are we going to communicate over? So we'll do a reverse shell. I want to do a interpreter shell since I set up that handler already. There's our IP and there's our port. So what the shell does in the background is it's actually going to fork itself off of the Splunk process so that it doesn't use up all the resources while I'm still communicating and attacking there. And then we have our connection there. So that's awesome, right? Everybody wants to install it. I have it on GitHub. That's a crappy link. Basically, weaponizing.splunk.com has it all. And then I also submitted it to Splunk for the Splunk base. It was really cool. I got approved. It took like 3 days. They were really cool about it. It was awesome. So instead of going to browse for file, you could just install it right from Splunk base. Except for about 57 minutes later, I got rejected. So I don't know who got in trouble over that. I've asked, but they won't tell me. But it was fun for a little while. If you go, I'll have them all at the end. But if it's github.weaponizing.splunk.com, and that'll have everything. It actually will have all the slide decks and the videos and stuff, so you can actually see them in proper lighting. So extracting data. All these applications that are installed on Splunk, Active Directory, Rapid7 has an app. Everybody has an app, and you have to install them. They have to configure them different ways. So some of these apps, for instance, the Active Directory application, needs a domain-level username and password. So what you would see when you're configuring that would be a screenshot like that. I'd have to install it, give it a domain, give it a user, and give it a password. Now Splunk is really good about it. They do store these passwords encrypted, and there's a salt and everything that is unique to each Splunk deployment as you install it. So if you go look at the file, that's what you would actually see in there. But if you have 14 lines of Python code, you can actually get clear text credentials. Damn, can we turn the lights down a little bit more? Dang, that sucks. Yeah. So about 14 lines of Python code, and again, it's all on GitHub. You can run that. You'll run it with your admin credentials that we obviously already have, and it loops through every application that's installed and extracts any information that it has in there. So if you could see that, we would have our username and our domain level password in clear text. And that works via the Splunk API. The Splunk API actually has access to all these configuration files, the salt, and everything else that it needs to decrypt those credentials so that when it does actually need to use those, it can communicate with the domain controller. Luckily, it's really nice, and it'll actually give it to me as well. So, now that we've already attacked the server, we have a shell in the server, we've extracted some passwords, let's actually move laterally in the environment and start working on other computers. So within the application, the Splunk Shells application, I built 2 technology add-ons, and again, these are just proof of concepts. They're using basic interpreter code. I'm not trying to hide from anybody. If you want to use them, I would highly suggest substituting your own custom payloads in there, and it's literally just swapping one Python file for whatever else you guys have. So the Windows add-on uses a batch file and just runs PowerShell code. I'm actually using the Trusted Sec Unicorn program to generate that, and just generates obfuscated payload for a reverse interpreter shell. And the Linux one is just a basic Python one, and again, I'm not trying to hide anything, it's all just proof of concept. So let's see what that looks like. That sucks too. Alright, so we're setting up another handler. Let's just skip through this a little bit. Inside each of these technology add-ons, there's a couple things that you have to change, one way or the other. All right, we'll just go with the dark. Let's just keep going up and down. It'll be a party. We'll have fun. So there's 2 things you got to change inside these payloads. Since they are just static payloads, you're going to have to change out your IP. So give it your attacker IP, give it your attacker port, and you do have to substitute in the PowerShell code because I didn't. It's not set up for, it's set up for me to use or somebody else. So you swap out your PowerShell code here. We'll swap out the Linux payload. I'm just changing our attacker IPs. Let's actually got our handler set up here. Let's actually go to deployment. All right, so here we are in the deployment server. So we have those applications. They show up here. It's literally just clicking edit, telling them what servers I want to install these things on, all of them obviously, and then it does all the heavy lifting of sending those out and actually running the code. What's really cool here is there's a configuration file for how many times you want this to run. I'm obviously just running it once, but I could say, let's run this every 30 minutes, or let's run this every 2 hours. So if somebody does detect me and kill me, I now have a way back in. It's going to call home here in a couple minutes, or an hour, whatever you set. So there, we got our first shell back, and then here in a second we should get our second one. Now it will take a little bit of time depending on the Splunk server configuration, how often the agents check in, and everything else. That's why it might take a little bit longer. But since we're an admin, we can change all that too. And so there is our second. So now we have 2 shells in the environment. But I mean, literally, if there was 100 machines, 200 machines, however many machines until Metasploit crashes, really, you could just keep getting shells back. I mean, I've had 60 or 70 call back in a matter of 5 minutes. So, bam. So that's really the cool stuff. Now I actually want to talk about the command and control. So we're going to be early for lunch. It'll be good. So I built another application. I just call it Weaponizing Splunk. And basically what I'm starting to do, and this is still a work in progress, is when we do a pen test, we have to run Nmap, we have to run NICTA, we have to run all these different tools, and every single tool generates some sort of output. So I'll do a pen test, and I have this really elaborate directory structure so I can organize all this information so that when I come back to write the report, that's going to take me another week and a half because I have to go through all this stuff and all this data. What if we just shoved it all into Splunk? So right here, I have a Wi-Fi Pineapple app, is what we're looking at. Immediately, in real time, I could run my Wi-Fi Pineapple, run my attack on there, but I have a universal forwarder installed, so all those logs are coming right into Splunk. So if I have Splunk up and I have my Pineapple running, in real time I know all the clients, all the SSIDs that I'm seeing. I have a nice little pretty chart if I wanted to send that to the client as well. All that stuff's already given to me in real time, and there's no parsing logs, there's no going back, and it actually speeds up that dwell time from running an attack and actually compromising moving laterally into the environment. And another one that I have is Responder. So Responder is the man-in-the-middle tool that actually will capture hashes throughout the environment. So in real time, again, I would have, I know how many credentials I have, I know the usernames, I know the domains they're for, I know the hash type, and then down at the bottom, I would actually be able to just extract in a nice little text file all the hashes really quickly so I can send it over to my cracking rig. And again, it just decreases that dwell time for you. So mitigating actions. Obviously, update your software. Enable SSL, change your passwords. In 6.5, it's really nice because they actually have 2-factor authentication now with Duo. So you can do that. All you have to do is change your password, enable two-factor, and that literally stops everything in here that I'm talking about, unless obviously there's password reuse or some other way that I got that password. Don't run Splunk as root, not even your universal forwarders. I know it's a pain to configure them, but take the time. It makes my job harder. Segregate your Splunk server on your network. Don't obviously allow all the connections to it from everywhere. I yet haven't seen anybody do that. I did have a guy last weekend in Nashville that was talking about he has it set up the proper way, but he's the first person ever. It'd be awesome to actually see it. But segregate it on the network. Don't allow the connections, and don't run it as root. I mean, that's really it. And then there's a really nice guide. It's about 30 pages long, but go through that and actually configure Splunk correctly. Any questions? I mean, that's pretty much it. There is the information. As I said, github.weaponizing.splunk.com or weaponize Splunk. I think I have both domains, so they both go to the same place. All the slides, all the videos. What's up?
So when you're backing out of a network, you also uninstall latency?
I do. Yep. All you have to do is the same way we installed them. All you got to do is delete them, and Splunk will actually do all the cleanup for you. Yep. Yeah, probably. In this payload, I mean, as I said, this is all basic payloads. These should all be detected, I would hope. But, you know, yeah, these are all basic payloads. I highly suggest if you're using this in a real engagement, I would swap these out for, you know, custom things that you guys run with your team. Yep.
With admin, you can also enable the delete command and delete any specific events that you don't want to.
Exactly. I keep forgetting to add a slide about that, but yeah, you could do cleanup as well. If there was anything that was logged, obviously these shells that are executing on the box would all generate Windows logs. If those are all getting pulled into Splunk, yeah, you could just do a search for it, pipe delete, and now all my traces are gone as well. Now it doesn't remove it from the box itself, just from Splunk. So if somebody actually did forensics on the box, they would still see that stuff. Anything else? All right, well, that's all I got. Whoop. I've built some reports for some of our customers that we do Splunk with, but I don't usually see that happening for people. So we do have some reports for detecting